Projectiles, inclined, inclined plane, type 1, landing on the plane. So this is 2006 question where we have particles projected up an inclined plane with an initial velocity of u. And we're told the line of projection makes an angle of 30 degrees with the plane, and the plane is inclined at 30 degrees to the horizontal. So the line of projection means it's going straight up the hill. And again, line of greatest slope means we're not veering off to the left or to the right. It's literally just going straight up the plane. So we're asked to find in terms of u the range of the particle on the plane that is inclined. So this is what we're trying to find. So if we sketch a diagram of what's going on, first of all, well, we have our plane. And we're told the plane is inclined at an angle of 30 degrees. And then we have the plane of projectile as vertical. So again, it's going up in the air with a projectile path with an angle of 30 degrees. And again, we're not told what the velocity is. It's just u meters per second. So in other words, in this case, alpha is 30 degrees and beta is also 30 degrees. So alpha being the angle with respect to the inclined plane and beta being the angle of the inclined plane itself. Okay, so to find the range, we're looking for basically the distance travelled along the plane. And we know that on landing, Sy will be equal to 0. So our range will be the distance in the x direction along this path. Okay, so what you're going to do is you're going to pause the video and check, have you got your table done out correctly for U, A, V, S and T, and be very careful because obviously we're on the inclined plane now, so we know that gravity is not going to be 0 in the x direction. We have to resolve our gravity. So again, if we think about gravity there for a second, just to remind you, seeing as this is the first inclined plane question, well, at any point on the path, gravity is acting in a downward direction. And therefore, if I'm resolving it, that's 90, that's beta. These two angles are vertically opposite. So therefore, if I do perpendicular component and parallel component, what we can see then is this is also a 90-degree triangle, and this is beta. So therefore, the angle within that diagram must also be beta. So therefore, the opposite here is going to be in terms of sine, and the adjacent will be in terms of cos. So in other words, when we resolve our gravity there, it's going to be g sine beta, but that's in the opposite direction. Let me just show you here. There's the initial velocity in the x direction and in the y direction. And remember, our initial velocity is what we're taking to be positive. So you can see both the gravity in the x direction and in the y direction has to be, has to be negative because they're in the opposite direction to the initial velocity. Okay, so I won't do that in any more of the inclined plane diagrams questions. You'll have to remember that. So that's just me reminding you of how to resolve your gravity for these tables. Okay, so press pause in the video and complete your table. Okay, so just as a reminder, your initial velocity is u cos alpha I plus u sine alpha in the j direction. So if we have alpha is 30 degrees here, well, that's going to become u cos 30 in the I direction and u sine 30 in the j direction. And of course, cos 30 is root 3 over 2. And sine 30 is a half. So therefore, our initial velocity in the x direction is going to be root 3u over 2. and in the y direction it'll be u over 2. And of course then if we're looking at our resolved gravity there, we saw that we had minus g sine beta. Well, sine 30 is going to be the same again. It's a half, and cos beta, in other words cos 30, will also be root 3 over 2 again. So therefore we have for the x direction, it's going to be minus g sine beta. So it's going to be minus g over 2. And in the y direction, it's minus g cos beta, which is minus root 3g over 2. Okay, so we know that v is equal to u plus at. So therefore v in the x direction is u plus at. And v in the y direction, again, is u plus at. S in the x direction is ut plus a half at squared. And S in the y direction, again, is ut plus a half at squared. So don't forget, it's a half times root 3g over 2, so that you end up with root 3g over 4. And of course, times in terms of t. Okay, so how are we going to find the range of the particle? Well, the range, we saw already that on landing, Sy is equal to 0. So this is going to allow us to find our time of flight. And our range is S of x. So once we know our time of flight, all we have to do is sub in for t. Okay, so we say on landing, Sy equals 0. So we take our equation for Sy, and Sy was ut over 2 minus root 3g t squared over 4. And I'm going to let that equal 0. I'm going to multiply everything across by 4. And then I'm going to take out t as my highest common factor. And then if both multiply to give you 0, that means both of these brackets, both of these factors must equal 0. So one is 0 or both is 0. And obviously t is equal to 0 represents at the start, the displacement will be on the plane, so therefore it will be 0. And at the end, if I get t on its own, I get my time of flight. So the second time that the particle is on the plane, in other words, the displacement in the y direction is 0, is when it lands. So this is our time of flight. So we're now going to use this time of flight to work out the range. So our range S of x is when t is equal to 2u over root 3g. And all I need to do then is sub in for S of x. So S of x was root 3u t over 2 minus g t squared over 4. So by subbing in for my time of flight, the time of flight was 2u over root 3g. And be careful here, it's t squared, so it's 2u over root 3g to be squared. So if I simplify that, well, I can see root 3 is gone, 2 goes into 2 once, which leaves me with u by u, which is u squared over g. And then here, if I square out my brackets, well, that gives me 4u squared over 3g squared. So again, 4 will go into 4 once, g will go into g squared once. So that leaves me with u squared over g minus u squared over 3g. And of course, 3g then is our lowest common denominator, which gives us 3u squared minus u squared over 3g. So S of x, in other words, my range, is equal to 2u squared over 3g. So we now have our range in terms of u and g, which is what they asked for in the question. So this is a 25-mark question. So if we go back to the start, what are they giving us marks for? Well, they're giving us marks for letting Sy equal 0. So that was our 5 marks. Then we were getting 5 marks for getting S of y, 5 marks for letting equal to 0, and 5 marks for our time of flight. And then we had 5 marks for our range equation and 5 marks for solving then. So that was our 25 marks.